Welcome to Electronics with Joe. I'm working on today a relaxation oscillator. For those of you that don't know, it's just a simple op-amp circuit, and you got an RC network here and a divider, some feedback. And basically, when you have different values of R and C, you get different frequency. So we're doing that, plus we're then feeding the output of this. We're actually feeding the ramp. So right here, you're going to get our ramp voltage, and we're actually feeding that into another comparator and setting up a threshold so that we can control PWM. And it's, people would say, oh, why don't you just use a 555 timer? You can, and I've done that, but the frequency changes a bit when you change the pulse width. And I don't want that. I want solid frequency, and I want solid PWM adjustment. And I don't want to use a microcontroller, and I want this to be as low cost as possible. So in doing that, this is a prototype board that I'm going to laser, and I'll show that process in the video too. So essentially, we're just using one SOIC-8 dual comparator too, because apparently comparators work better for this. So as you can see, I have labeled here. So this is the first comparator. This is the second comparator. So the outputs are labeled Y, input negative, input positive, ground, etc. And so how I do these boards is it's a defined dimension, so 70 by 110 millimeters, and I'm doing it on FR4 double-sided. So I know that my bottom layer is just full ground, and that way I have full ground on the bottom, and then I have ground pour on the top, and then I have 1 millimeter clearance through here through the pour. So any ground islands that get created, like for example this island right here for this ground, instead of having to fly wire this over to this ground pour over here, I can just pop a few holes through here and just do a soldered in via, and then it's a lower inductance way of doing it. I don't think it matters quite as much for this stuff, but it's good practice. So you'll see that too in this video. I'm going to try to make this more than just a screen talk, like you'll see other stuff too. So, but anyway, this also sort of serves as a good archive for myself too, because when I do this kind of detailed work, months go by, and then I'm sort of wondering, what did I do here? So what I have right now is the two of these. These are just low profile SMD wire to board connectors. They're toolless, which are nice. So they just go on here. So then we have, this is their power input, so like up to like 24 volts. Then it goes up here to our 5-volt regulator. That's just a cap on the input. That's all ground. This here is the output, another cap on the output. Okay, and so we do have to do a fly wire from the output to positive to power the op amp here, but that's fine. I think that's the only one I have to do. So that's power. We've already covered ground. And so when we go back to the circuit, we got to get our feedback from output to negative and the capacitor from negative to ground, right? And so I just standardize on 1210 SMD components. It's just a good size because they're small enough to be nice and convenient, but they're not too small to be hard to work with. So what we do is we need output, right? So we have the output of the first op amp, right? And it is going to the, what do we have here? Sorry, the negative. I gotta look at this again. We got, yeah, output to negative and negative to, yeah, so output of the first one, right? So it's, and we're not using a resistor. We're trying to make this adjustable, right? So we have a potentiometer here, right? So we're going to go from the output. So if you follow this, this is the resistor here through the pot and then back to the negative. So I have a few squares here for test points. Another test point here on the output. Don't worry about that for now. So that's the resistor. And then this is actually the capacitor down here. So if I show this here a little better. So this is just a selectable capacitor situation. So I can put a few caps here and I can select. And these are nice, convenient little jumpers. These are 1.27 millimeter jumpers. Pretty sweet. So that right there is how we're doing that. And that's a good example of how I'm making this usable and making it for what I want. I'm not just putting two components there, and, you know. So that covers that part. And then the other divider from output to positive and from positive to ground. So output here through the resistor into positive, another test point, and then another resistor to ground over here. So that's everything there. And then, so that basically covers the oscillator part. And so what we're doing after that is kind of neat. So we have a ramp voltage. So let me just explain this quick. So let's do, let's just draw this. It's just going to be super quick here, but that's okay. We can do this. So we just have our voltage here. Let's go with a thicker line, shall we? Somewhere you can adjust that. Tools, brushes, I guess. We just go with this. No, not that brush. We don't want that brush. Let's go with this brush. So we have voltage, right? So we've got voltage here, and this is time, okay? And so when you put a scope on the ramp node of this, which is right here, so right at the capacitor, right there, you see your typical ramp, right? You're going to see this sort of. It looks a little different than this, but that's basically what it is, okay? And so it turns out that has a DC offset of about, I think it's like 2.5 volts. Okay, so you can then imagine if you put a comparator, if you feed this into a comparator and you set an adjustable window right around here, then you can get nice consistent PWM going on. So that's what we're doing. So, and this is all this is. It looks kind of crazy, but all it is actually, let's draw that too. So let's do a new one. So when you're looking at it from that way, you've got your 5 volts here, and then essentially all it is just a resistor, and then it's the other resistor. Okay, so that's the pot right here, and then you have the wiper from the pot here. Okay, so we have 5 here, and then we have 0 here. Okay, and then so our midpoint is going to be 2.5, and we just set these resistors to be that way. The only reason you see multiples here is just because I don't have the exacts, so I'm just giving myself room to conjure up what I need there. And then this gives us that adjustable window, right? And then so what we can do is we just feed that. This is just a capacitor on the wiper to help with noise, and then it feeds right into the negative of the second comparator. Okay, and then the positive, I have to do another jumper here, but the positive is just going from the output sorry, it's not going from the output, it's going from this node here, which if I can get this on, It's going from this node here, right from the capacitors, right? That's where the resistor and the capacitors meet. So we're doing one other fly wire. So there'll be 2 fly wires on this board. So one here, and it's going over to there, and then our output here is open drain. So we have a 5-volt resistor here, an LED, another jumper, just for troubleshooting, and then back to the output. So that's how we are going to do this whole board. So that's pretty much it. And I don't get caught up in, not caught up, you know, math is good, but I don't really worry about the values of R and C and all that stuff. I'll figure that out later. Doesn't really matter. I just want to get this board here because it's the prototype for what I'm imagining, right? What I'm imagining is a nice small circuit that's repeatable that I have for the rest of my life that can do exactly what I want. So perfect. So now what we'll get into is the actual fiber laser process. So what I do is I go, actually, but first what we're going to do is bring in the logo, because I want to put a logo here. I got a nice new logo for this, so just bear with me. I'll be right back. So actually, I figured I may as well show how to do this too. So I'm going to import my new logo in here. So I'm trying to crop it. So I'm going to snip this, and I'm going to save it into EJ logo. So it's just my new logo, Electronics with Joe. Nice and simple. And so we're going to go with that. We're going to go back to Easy EDA. So this is how you do this. So you go File, is it File, Import, File, Import, Image, select the image, and then we can go Insert Image. And so there it is, but it's way too big. So we are going to, we probably want that a quarter of this size. So File, Import, the logo again, and size, so a quarter, so we go, let's go 30, and insert that. Let's see, yeah, that's perfect. Okay, so we're going to get rid of our ground pour. So to just turn that off, another really good tip is when you're doing the ground pour, draw your border so it's a little farther out of the board so you can actually click on it. Then you just go over to, you can't see it on this screen here, but let's see if I can make this a little easier to see for everybody. So you go, what you do is you go to fill style, no solid, so it just gets rid of it. And then we're going to put our logo probably right there. And then we make sure that this, whatever net this is on, it's top layer. I can't make a net. Okay, that's fine. And then we will do our solid again. And there we go. There's our logo on there. Pretty cool. So that is that, and I will now show the rest of the process. So we're going to do File Save, and then File Export as a PDF, like so. And then we want top layer. We're not going to bother with the silk layer, because what you can do with the laser, I've done this before, is you can do a separate export with the just the silk screen, and you can do a quick light pass, and it does mark it up with the silk screen, but it kind of causes some problems when you're soldering if you hit it too hard, and it's not really worth it for right now. We'll keep the board outline and everything else. So we will export this as 1-to-1. We will bring it up here. So this right here is our circuit. So we'll use snip again. And now we have to be very careful to snip this inside of the board outline as best we can. Okay, so now we've got it snipped. We will save this as something we remember. Save that. And so now we go and open our favorite software called Lightburn. That's funny, that looks like a face. Right here. Can't zoom in on that. Can I? No, it looks like a face right here. That's funny. Like with anyway, we are going to open Lightburn and bring it over so everybody can see. All right, so you do file and you do import and you import your stuff. Okay, so we stick with 1575, but the main setting that you need to change, and this is, I don't know where else you're going to hear this, because you need to go and change image mode to threshold. Because if you do others like this, you will get, when you look under the microscope on the traces, you will see the edges they sort of look like this. And you don't want that. So you want threshold, which is right here. And then what we always do too is do our preview. So to check our moves and cuts, so we know anywhere that's red will be a move, anywhere that's gray is a cut, and that's what we want. So there's going to be copper everywhere except for where we don't want it. So that's good. So we've done our preview and everything's fine that way. We can go okay. So we're basically ready to go. So now I'll switch over to the other camera and we'll show how that process goes. So here's my setup. I got the ventilation going. There's my laser. Just turn this on quick, turn the key. If I can from here. Should turn on. There we go. Alright, and now we're just going to hit go. And there we have it. So it takes a few passes to get it all in, but this video is going to be the first one, and you'll be able to see how it works. I found that the most important thing is trying to get the copper clad level, because the focal length is very sensitive to distance. So you could end up with part of the board closer and part of the board farther away, and then you end up having to do more passes than you want, so then you end up with part of the board that's more backed up than the other. So in this process, I've worked very hard. I put a lot of hours into figuring this out. I've done a lot of different ones over the years, and my goal was I want to be able to press a button and then have a board in 30 minutes or less. So that's the whole point too with the surface mount components. There's minimal drilling, if any at all, on these boards. And it's very quick, and as long as you don't over burn them, there's no smell or anything like that. Even on FR4, and I've heard other people say that they have problems with doing FR4, but if you get everything right, if you do it right, you don't. So there's the logo now on there. That's pretty cool, right? And it looks like we're getting a good even pass. Looks even better, except you can see on the bottom left, it looks probably okay. So there it is. We're almost done the first pass. Pretty neat stuff. There it is. So turn the light back on. Oh, it's on again. Okay, that's fine. We'll just let it go. You can see here. Looks pretty good. Here it is with the light on. A little better. So it'll probably take about 4 or 5 passes or so, and then we'll have it all. So this is about, I think, 4 passes in. Zoom in and see what's happening to all the copper. It's looking pretty good. Still got a ways to go. You can see the lines in there, right? So I know I said 4 passes or something like that, but it's going to take more. And you can see how, like, over here, it's better than it is over here, right? And that's because there's a slight difference. It's not perfectly flat, even though I do have it double-sided taped to the MDF. It's still not perfectly flat. But you can see how if you could get it perfectly flat, you'd be even quicker because you get even more even passes. There you go. That's a perfect example. See now. See, that's the fiberglass. That's the just hit it, and that's perfect. And I think this might actually be the final pass because I don't want to risk. See, look at that, nice hash marks. Perfect. Yeah, this will be the final pass. See up here, it's a little iffy, but that's fine. I'd rather preserve everything else because it's not burnt and we just kissed it. It's perfect. And I'll just use a scalpel on that part if I have to. So, not afraid to use a scalpel. So, I'm going to get over here to stop the laser. And then I'll show a good close-up of it. Alright, there it is. Done. Turn this off so we can see how we did here. So there we go. Not bad. That was definitely under half an hour. And so you can get an idea of how clean this is. See, there's a reason that I standardize on 1 millimeter trace width because it ends up a lot smaller by the time the laser gets through everything. But see, there's our SOIC 8
chip ready to rock and roll. There's the logo. Looks great. Really happy with this one. This is the results of many tests, let me tell you. So, cheers. All right, so I don't know if you can hear me. Sorry, my fiber laser's running in the background. Anyway, this is the relaxation oscillator in the duty cycle comparator trigger circuit that you saw before. The last time you saw this, it was just the lasered board. Now I've got the components on there. I only used one capacitor network because that ended up getting me the right frequency. Anyway, so what I wanted to show was, you can clearly see in purple, you can see the ramp that's created by the RC network and the feedback of the first comparator. And then that ramp is fed into the second comparator. And I'll take a clear picture of this and do a walk and talk through the board later, but it basically, that ramp gets fed into the second comparator and compared against the threshold voltage, which is adjustable with this here. So this does the frequency. Okay, that tunes the frequency, and this does the PW. This does the duty cycle. I keep on saying PWM. It's not. It's duty cycle. So as you can see, I can get really tight on this. Right, you can barely see it's there, but it is there, and I can zoom in. You can see how I can get. See, the output needs a Schmidt trigger on it, you know, and it's my first round. It's a little touchy, but it works pretty darn good because I can go super tight and all the way back out, right? And again, this is pure analog, right? This is all analog with a 70-cent comparator IC and a few components. So I just wanted to show, there it is working. I've got 20 volts in, the regulator's doing its job. There's LEDs on the board, and you can see the bottom LED fades in and out with the duty cycle as well. So that's good. And then I'll do a picture of the board and a walk and talk through it. I just kind of wanted to show it powered and working the way it was intended. So this prototype, I'm going to shrink this down obviously, but I'm going to use this one and feed it into my pulse board to drive that, and then eventually it'll all get shrunk down into one tight module to be able to use. So here it is. Cheers.